Okay, thank you everybody for attending. Thank you for this opportunity. It's my pleasure to provide a quick overview about the main results of the ePANACEA project. My name is María Fernández, as Alexander said. I am a researcher and senior engineer at the Transition City Department in ENER, the National Renewable Energy Center of Spain. I am the project coordinator of ePANACEA. Sorry, because probably since I am the last one presenting, I am going to repeat some of the concepts that my colleagues have just presented. Regarding a general overview of the project, ePANACEA Project Consortium involves 10 organizations from 6 different European countries, including 4 research centers, 1 university, 3 energy agencies, and 2 small companies. The project started in June 2020 and was originally due to end in May 2023, by the end of this month. But we have applied for an extension, so it will probably end finally after this summer. Then why ePANACEA? No? This is regarding the motivation. I think all of us agree that energy performance certificates have the potential to play an important role in the energy transition, in achieving the European Union environmental objectives. But, however, for the EPC to reach its full potential, several current challenges need to be addressed. For instance, and in my view, the most important one, as my colleagues have commented, the gap between standard outcomes of EPC schemes and real consumption patterns, leading to inaccurate energy savings estimations from the implementation of energy efficiency measures. A lack of accuracy of the building's energy assessment results, a poor awareness related to energy efficiency from the end user perspective, a lack of convergence also across the European Union, for instance, about assessment methods and tools, calculation intervals, minimum requirements for the EPC report, and so on. Also, a lack of appropriate protocols for integrating smart and novel technologies into existing workflows. And finally, a lack of market trust in this instrument. So the main objective of ePANACEA is to overcome these challenges by developing a holistic methodology for the assessment and certification of the energy performance of buildings. Now, to achieve this main objective, we have defined an overall concept that involves developing innovation mainly on these 3 pillars. The first pillar is the next generation of features related to input data, such as a better consideration of user behavior and occupant patterns, and incorporating smart and novel technologies such as on-site production of renewable energy and the use of monitoring data also to increase accuracy. The second pillar would be the next generation of results, including new indicators, such as new global and partial indicators better understood by end users, recommendations based on user behavior, and also tailored recommendations based on a cost-optimal solution for deep renovation of buildings. In this pillar related to results, we also want to include a double orientation of the information included in the EPC. On one hand, focus on the needs of the administration based on standardized operational conditions to provide this objective comparison of the building stock, but on the other hand, a focus on the needs of building users as well, based in this case on the actual use of the building. And finally, the pillar 3 covers the next generation of tools because a next generation of EPCs requires a next generation of web-based tools and their innovative capabilities. In this case, the entire ePANACEA methodology has been implemented into the SEPAP, the Smart Energy Performance Assessment Platform, that integrate inverse modeling and automated calibration procedures for dynamic building energy simulations. Well, the ePANACEA methodology includes 3 different energy assessment methods with different approaches and a decision matrix to recommend the most suitable one for each case. The first one is the Smart and Performance Data-Driven of Building Energy Performance Assessment. Focuses on the use of monitoring data sources to complement the existing EPC schemes covering normalization and calibration of annual use. The second one is a simplified method based on monthly calculation interval. This is based on the methodology provided by the Standard 52016 as part of the set of standards developed under the Commission mandate. And finally, the third method is the advanced and automated simulation modeling based on dynamic simulation for EPCs. That implies the development and optimization of a procedure for the use of dynamic simulation and auto-calibration of white box building energy models, including the improvement of the effectiveness of the whole process in relation with the state-of-the-art of this type of assessment. Well, related to the tools developed under the project, we have developed several tools to support the assessment method workflow, focused mainly on taking advantage of running models on the cloud, using computational powerful servers to minimize the use of time, besides with the implementation of automatic approaches for each step of the workflow, for modeling, calibration, calculation, cost-optimal assessment, and results. In addition to the online platform, a global installation package of the CEPAP tool has been developed for local installation on the user PC. This tool includes advanced functionalities to improve the cost-effectiveness of the building energy model and auto-calibration. In addition to the energy performance assessment itself, additional calculated indicators to the EPC, such as the SRI, comfort, and indoor air quality indicators, have been implemented through these tools. Well, the methodology development is the core of our project, but it has been also supported by a triple feedback loop to ensure the quality and impact, as well as the reliability, user-friendliness, and cost-effectiveness of the whole methodology. Each of these 3 feedback loops can be used to support a specific target of the project. Workshops on the needs on the needs and perception of the end users have supported, for example, in terms of user-friendliness and clarity of information provided. Activities in the context of the Regional Exploitation Board, 5 Regional Exploitation Board, have supported in get feedback in relation with global aspects related to overall targets of the European Union. And finally, the third feedback loop is the testing and demonstration of the methodology through the assessment of the case studies in the 5 pilot countries, is validating the methodology from a technical perspective in terms of accuracy and cost effectiveness. Well, a little bit more about these three feedback loops. ePANACEA has conducted a total of 15 workshops during the project lifetime, 3 per pilot country, focusing on the integration of end-user perceptions, needs, and feedback. This has allowed to identify what information and how it should be provided to end users in terms of user-friendliness to increase market confidence in this tool. The ePANACEA project has managed also 5 regional exploitation boards covering the European Union through 5 geographical regions, as you can see in the slide, comprising European policy makers, certification bodies, consumer and professional associations, and other relevant stakeholders from the European Union. Finally, the ePANACEA methodology is currently being validated through the development of 15 real case studies, 3 per pilot country, covering very different climatic zones and a wide range of building typologies and data availability scenarios, including single-family houses, apartment blocks, offices, and educational buildings. For more information and access to most of the project's open source, open access resources, please visit our channels, such as the project website, but also for your convenience, the ePANACEA Zenodo community, the GitHub repository, and the YouTube channel, where several video tutorials are currently available. So, thank you so much for your attention. If you prefer, contact us via email.